Okay, in this video we're going to look at titration calculations. I'm not going to talk too much about the practical side of it. That's covered in a later video. What is titration for? It's where you use it to find out to work out the concentration of a solution that you don't know the concentration of, using another solution that you do know the concentration of. Usually you put alkali into the conical flask, and it's usually 25 centimeters cubed, which you add very accurately with a pipette, not with a measuring cylinder. And then you put indicator in there as well, usually phenolphthalein. Other ones you can use, phenolphthalein, which is purple in alkali, and it goes colorless when it's neutralized. And you put the acid into this thing, which is called the burette, and you keep adding the acid slowly until from the indicator color you can tell it's been neutralized, and then you can record accurately the volume of acid. Okay, so that's what you do, and probably the best thing to do now is to just look at an example question, and we'll work through that. Okay, so here is a question, right, this one here. Okay, now have you noticed you've always got to be given the equation for the reaction, because you need to know the ratio in which the moles and the reactant with. So here, what we do here is we've got 25 centimeters cubed of NaOH, it says there, which is placed in the conical flask. And we don't know the concentration of that, so put question mark there. In the burette, we put in hydrochloric acid, and the concentration that we do know is 0.112 moles per decimeter cubed. And we know what volume of that we need. We need 28.1 centimeters cubed to neutralize it. Now let's look at the equation. The equation shows us there for every 1 mole of sodium hydroxide, sorry, we are going to need 1 mole of hydrochloric acid. So it's quite straightforward, this one, to 1-to-1 ratio. Okay, we're going to have to use this equation, so I'll pull that down there. Now, I'm going to make a little table here. Well, NaOH, which I'll do in yellow, and I'll do the acid, which I'll do in orange. And here, there's 3 things in this equation. There's the concentration, there's the moles, and finally there is the volume. Now we're going to fill in what we know about in this little table here. Okay, so let's look at the NaOH. Right, do we know the volume? Yes, we do. It's 25.0 centimeters cubed. We need to convert that to dm cubed, so divide by 1,000, that's 2.5 dm cubed. Do we know the concentration of that? No, that's what we've got to find out. And we don't know the moles of NaOH in the reaction either, how many moles we're reacting. Right, let's have a look at the hydrochloric acid then. The hydrochloric acid, do we know the concentration? Yeah, they tell us it's 0.112 moles per decimeter cubed. Do we know the volume? Yeah, 28.1 centimeters cubed. Divide by 1,000 to give it in dm cubed. It's that many dm cubed. Let's write that down there. So can we work out the number of moles of HCl that are reacting? We can, because whenever you know 2 things in this equation over here, whenever you know 2, you can always work out the third. So let's work out the moles of NaOH, so of HCl. The moles of HCl is going to be the concentration times the volume. The concentration is 0.112 and the volume is 0.0281. Do that on a calculator, and it's probably going to give us it in standard form, and we'll just leave it in standard form. That's fine, and avoids mistakes. Right, so that gives us that's 3.1472 times 10 to the minus 3. Now we need to look at our equation. The equation tells us 1 mole of sodium hydroxide reacts with 1 of HCl. So how many moles of NaOH have we got in that flask? It's the same as that, because they react in a 1-to-1 ratio. So that's going to be, do that in yellow, sorry. That's going to be 3.1472 times 10 to the minus 3 as well. Now we are in a position to work out the concentration of our NaOH, because we know 2 things. So let's do that. I'll just rub that bit out there so we've got space. concentration of the NaOH is equal to the moles, which is 3.1472 times 10 to the minus 3, divided by the volume, which is 0.025 dm cubed, and that gives us an answer of Right, do my calculator, says 0.125888. Now, moles per decimeter cubed. Because everything's given to three significant figures here, if you look at that, three significant figures, that, three significant, and so on, this should be given to three significant figures, so I'll get rid of that, and that should be a 6 at the end, shouldn't it, there? Rounded up to a 6. Mole per decimeter cubed. And that is our answer. That's the concentration of the NaOH to three significant figures. Okay, let's have a look at another one then. Just get rid of that. And this one will be a bit more difficult because you won't have a one-to-one ratio of the moles reacting. Okay, so we'll just rub this stuff out. Okay, right, and that as well. Right, there's our second question down there, so I'm going to grab that. Make it bigger. Okay, so let's see what we've got here. Once again, we've got NaOH, we don't know the concentration of that, and that's in the conical flask, 25 centimeters cubed, that's the volume. And we don't know the concentration. In the burette, this time we've got sulfuric acid, okay? And we know the concentration of that is 0.105 mole per decimeter cubed. And the volume of that, we're going to need 23.4 for neutralization. 23.4 centimeters cubed. I'll convert that to dm cubed when I'm here. 0.0234 dm cubed divided by 1,000. Let's do this one as well. This is going to be equal to 0.025 dm cubed. Right. Now we need to look at the equation, and this is where it's a little bit different because, look, the NaOH, 2 moles of NaOH only react with 1 mole of sulfuric acid. So we're going to have to take that into account. Right, so do our little table again. Then we're going to use this equation. There's 3 things we want to know there. We want to know them for the NaOH and for the sulfuric acid. Right, so we want the concentration, we want the moles, and we want the volume. Fill it in. So the sodium hydroxide, we don't know the concentration, we're trying to find that out. Moles we don't know yet. The volume, that's 0.025 dm cubed. The sulfuric acid, we know the concentration, that's 0.105. And we know the volume, which is 0.0234 dm cubed. Right, so that means we can work out the moles of the sulfuric acid using this equation here. So we're going to rearrange moles of the sulfuric is equal to conc times volume. That's 0.105 multiplied by 0.105 multiplied by 0.0234. Right, so that again is going to give us a number in standard form. We put it in a calculator. So 0.105 times 0.0234, 2.47 times 10 to the minus 3, or 57 times 10 to the minus 3. So I'm going to fill that in this column here. So that's the moles of sulfuric acid, which is 2.457 times 10 to the minus 3. Now the equation here, 1 mole of sulfuric needs double the moles of NaOH. So the moles of NaOH is going to be double this value. So we're going to have to double that, 2 times 2, so times it by 2. We get 4.914 times 10 to the minus 3 moles of NaOH. Now we know both things. We know the moles, we know the volume, so we can work out the concentration. Let's do that. The concentration of the NaOH, moles over volume, 4.914 times 10 to the minus 3 divided by the volume, which is 0.025. Okay, that gives us 0.19656. Again, we should give it to three significant figures, so that means that last 6 is going to turn into a 7, and the units are moles per decimeter cubed. Okay, so there's a second example. Right, now there is one more which I'll do, and after I've done this, at the end of the video I'll just give you the questions, no working out, and I'll give you the answer and you can practice them yourself. Okay, so I need to rub all this out. I'm going to get rid of this question here, paste in the new one. Gone. Right, the new question is down here. Okay, right, so here again, right, it's the sulfuric acid and the NaOH one again, so we've got the awkward ratio, 2:1 ratio to worry about. Okay, so let's see what we've got in the conical flask. We've got NaOH again, 25 centimeters cubed. That's 0.025 dm cubed. And we know the concentration of that this time, it's 0.115 moles per decimeter cubed. And in the burette, we've got sulfuric acid, and we don't know the concentration. That's what we've got to find out. But we do know the volume, that we needed 27.3 centimeters cubed of sulfuric to react with that much NaOH. So once again, let's do our little table. We'll have NaOH in yellow and sulfuric acid in orange. There's three things from this equation that we need to know about each of those substances. We want the concentration, we want the moles, and we want the volume. The NaOH, yeah, we know the volume. That's 0.025 dm cubed. We know the concentration, 0.115. The sulfuric, we don't know the concentration. Right, we know the volume, 27.3 centimeters cubed. Convert to dm cubed, divide by 1,000. We get that. So 0.0273. Now, we know two things about the sodium hydroxide, so we can work out the third. We can work out the moles of sodium hydroxide. So moles of NaOH, conc times volume. The concentration is, what is it? It's 0.115 multiplied by 0.025. That's equal to 2.875, okay, times 10 to the minus 3. Again, in standard form, we'll just leave it in standard form. So that's 2.875 times 10 to the minus 3. Now, what is the volume of sulfuric acid there? What's the number of moles of sulfuric acid? Well, 1 mole of sulfuric reacts with 2 moles of NaOH. So we've got that much NaOH, we need only half that much of the sulfuric, so divide that by 2. 1.43 times 10 to the minus 3. Now we know the two things there. We know the moles, we know the volume. we can work out the concentration. So the concentration of the sulfuric is equal to moles over vol is equal to 1.4375 times 10 to the minus 3 divided by the volume 0.0273 dm cubed. Okay, that gives us an answer of right. So I'll copy down the number for calculator and I will write down it properly, the number sig figs. So we've got 0.05265. We should give it to 3 significant figures, so I should change that 6 into a 7. That's 3 significant figures now, and the concentration units are moles per decimeter cubed. And that's that one done. Right, now, not going to do any more, but if you want to practice, there's some questions here. Just make these a bit bigger. Okay, so it gives you the questions there, and it gives you the answers, so you can check, see if you've done it right. Okay, we'll leave that there.